Okay, so let's talk about these chucks. You can remove the main chuck and put on this, which is called a Centrotec chuck. And what it allows you to do is change from the screwdriving torques to standard screwdriving Phillips or pausing. Again, one-handed onto a drill bit, which is quite useful. Now that's why that does lock in completely, which is quite useful when drilling pilot holes and then moving to a screwdriver. And of course there's a function on top of the drill to allow you to engage and disengage the torque section. So let's have a look at the two chucks, see how they're made and see what's inside them that allows them to do this. So let's start with the smaller one. Again, this is called a Centrotec chuck. It uses the Centrotec system, which is what this section of the drill bits are. Again, I believe these are made in Italy for Festool. I'm not sure the manufacturer of them, but again, if you run your finger along them, you can see that these have actually been ground, which is a good feature. So, like many of these parts are held with a small circlip. Let's see if we can get that open. Now, I have done these before, and sometimes they come apart very, very easily, and sometimes they are very difficult and tricky. Now, of course, there are other elements inside this. It is actually sprung, so it is difficult to hold it actually compressed and still get a good, let me try it this way here. It's getting enough force in it that it does pop out over the top. Now, if any of you out there know a better way of doing this than what I'm doing, please comment below and we will most certainly do it next time. But that was very nearly it there, so let's try again, just using a little more force, and possibly let's set a screwdriver in here just to hold that, and out it comes. So let's remove this and let's set these along here just as we normally do. So again, this is held with what looks like just a cover cap. I assumed that this was actually part of the same system, but of course they moved differentially, so they must be separate. So this is quite heavily sprung as we lift it up. Again, a branded part, a branded molding, and no markings inside. But you can see that there is a definite change in the inner circumference, the ID measurement, which does allow, whenever this is travels axially along the metal part, to create and not create room for the ball bearings to move to the left and right into the gallery. So here's a small spring, which has actually been ground on the bearing face. I don't see any marring of the actual plastic parts, so it must have been done prior to manufacture. Now we have quite a few ball bearings in here, which we would expect because we can see them when we look down here, and again they move axially. Sorry, they move perpendicular to the axis of this. Let me just take these out. And we have another one here. Let's try not to lose these. Now, what else do we have? So this part is fixed and this part will slide off. Now let me just make sure that any more ball bearings don't fall through. Here we are here. So there's another one, another two, and again another third. So this is the main element, the main part of this assembly. So we can I'm not sure if you can hear that. So it is definitely machined. And we can actually see the machine lines on it. So it's not a centered part, which is good. And that there are quite a lot of turnings required on this. Again, you can see this is the groove for the circlip that was in, and then 2 or 3 grooves on down. I'm not sure actually what these are for, whether they're necessary or not, but they've even chamfered this edge, which is quite a nice detail. So of course we can see how this works now, that if we take the actual parts that are used in it, and when they're inserted into it, you can see that this section here aligns with these 3 holes and allows the ball bearings just to drop in to those areas, and that retains this fixing, or this bit within it, and it retains it at the right position to allow it to travel right through and to present the hex head on the other side of it. And the hex head then is what travels on into the drill bit and uses the force from the drill to travel on through. But this is still free to spin, which is quite, yes, it's quite good in that if you're to instead of fixing in and this was to come into contact with the wood or the steel that was using, then this would continue to spin round where the fixing wouldn't. Again, it's a very tight fit on it, and there's very little axial play in it. So that gives us an idea of what's involved in a very small part. Again, this part I think is about £30. So not massively expensive for the amount of work that's involved in doing it. So let's try and put it back together again before we lose any of these parts. I suspect I'll maybe get a stronger magnet next time. I suspect if we put these ball bearings in first of all, and then we put the blue collar around it, that will hold them in place. Maybe a little grease in these would have helped just to allow them to stay still. Okay, so let's put the blue collar back on. Actually, let me put these higher level ball bearings also in, because I think the lower collar will actually hamper space just to get in there. So that slides over there. So that's now retained those ball bearings at the bottom. Then we put our screw on top of it, or sorry, there, our spring on top of it, again, which is quite stiff and appears to be stainless as well, which is good. So that rests there. And this part rests over the top of it. Again, it is quite a high compressive force required just to do that. And then, so that this part at the bottom is just to center this on that. Yeah, so that doesn't actually travel up and down, it is just this part that travels. So you can see that, let me just finish the assembly first of all before any of the ball bearings are lost. We can fix this small circlip back on again. Quite simply actually. So you can see what that allows it to do. You can hear the spring movement. So this will slide up and down here, which allows the ball bearings inside to move out of the way, and then this slides up and down here, and that allows the other ball bearings to move. So it's quite a nice little part. Okay, let's have a look at this one and see how this one works. It looks to be in a very similar manner, in that we have 3 ball bearings here. This moves out of the way and lets the ball bearings release into a gallery at the side. Now, I'm not sure how this comes apart. It doesn't seem to be... yes, we have another circlip here. So let's take the bottom one off first of all and see how we can get on. Now there's quite a bit more movement or space here, so yes, that worked a lot easier this time. Let's line these up again. So if I take this off again, another quite strong spring. Just let that push itself off. So again, we have a plastic cap around a metal bearing race, and another stainless steel spring. This spring actually is tapered, so it's thinner at the bottom and wider at the top, and there is a ledge here for it to rest on. Again, we have 3 ball bearings, so let's take those out before we lose them. And that. The same standard ball bearing size. And I'm not sure what these parts are. I think these are the jaws, the actual chuck jaws have come right through here. So that's what this void or this space is for, to allow those to travel whenever they're fully open. We can see those traveling down into that void. And that sets the depth. That's why these need to be as deep as they actually are. Now, this is mostly plastic, but as we can see, there's quite a bit of heft and weight into this, so it is metal on the inside, and a metal cap along here, which is again quite good if this was ever to make contact with the drilling surface, that this will spin, and I suppose it allows you to hold it whenever that's drilling as well. So let me see if we can open this as well and see what's inside. That's very nearly there. Oh. And we lost that one. That's okay, we'll gather that after. So this cap comes off, and then is there another? No, there's no spring in here at all. So that is just a cap. Now, a lot of these would actually be metal completely on the outside, so I'm not sure why they decided to change to a plastic cap. I know a lot of these tools are used for cabinetry and things where it's careful that the surface, that if any of the tools actually made contact with the surface, that it didn't damage the surface. So maybe that's what it is there. So again, we have a mostly inside metal part, which is again looks like a metal. Yes, it is. You can actually see the turn marks on it. So I don't think it's a sintered part. Many of these tools, actually, when you take them apart, you'll find that they are sintered now. So it is quite possible that Festool will go this way as well. But there's quite a difference in the colour as well between these two parts. So these jaws are obviously hardened, and a lot of these actually have a separate insert tooth in here, which are hardened, and then the jaw itself is not, but it looks like the whole part. I wonder if I screw this out, will it come apart? It's getting looser, let's see. Nope, so there is a physical stop there, and there is a gearing of some sort in there which is stopping that. There is a depression here, but it doesn't seem to do anything. So again, anybody out there knows how to take this apart a little bit further, it would be good to know, and we'll take it on down. But again, quite a bit of engineering involved in this part. And you can see there's our hex, which mates onto the other obverse on the drill. So let's see if we can put this back together again. Now, of course, we lost a piece, so we'll have to see if we can find that easily. And if not, we can put it on after. So that circlip would go around there. So let's just turn this around. And first, we will put the ball bearings back in. And a third. We'll set this on, making sure that this, if we were to set it on the other way, it will travel over the top of that, which would interfere then when you open the chuck itself. So this sets down here. And then our circlip around the outside of it, which does hold it all nicely in place. Now the advantage in the circlip, of course, is that in a lot of these tools they are designed to be used. Is that located? It is indeed, yeah. You'll find a lot of the other tools actually are circlip because of the there's no chance of it loosening by itself. It's under force. It's unlikely to open and then leave an element behind if it was to be used somewhere. Now let me see if I can find this other circlip real quickly. It can't be too far away, and there it is. And that will just allow us to bring all this back together. We seem to be a little high here. Is there an engagement for this? Not sure if there's one way this goes on. And, yes, there is indeed. Okay, so that sets down, this sets over, and then our circlip goes over the top again. And let's see if we can get this on quickly, because sometimes it can be quite difficult to. Some of these are much tighter than the others. The one at the back wasn't very tight at all now, but this one is quite a bit stiffer. Whether it needs to be or not, I don't know, but someone has decided that it should be. Let's see if we can open it up slightly with this tool.